Welcome in another video. Today we are going to discuss the functional groups, specifically the oxygen-containing hydrocarbons derivatives. Okay, we will start with alcohols. An alcohol is simply an R group, alkyl group connected to a hydroxyl group. So let's take some examples. Something like this, CH3, CH3, OH, or something like this, C2H5OH, or simply C3H7OH. It doesn't matter. We can see that the common group here is a hydroxyl group, as we can see here. So this OH group is called a hydroxyl group. So as long as you can see an OH group in an organic compound without any other groups, simply if you can see an alkane, and in this alkane an OH group, a hydroxyl group, then don't think about it. This is an alcohol, okay? But if you have multiple functional groups, this is a different story, okay? I'm just talking about an alkane or an alkene or an alkyne containing a hydroxyl group. This is for sure an alcohol, okay? So let's move on to the ether. So ethers. Ethers is all about an ether linkage. Oxygen in the middle acting as a bridge between two alkyl groups or two aryl groups. So it could be the alkyl groups could be the same alkyl group, so it could be R1 and R1, just like this, CH3, OCH3. So CH3, a methyl group on the left side and another methyl group on the right side. Or it could be something like this, R1, O, then R2. The R1 could be a methyl group, and the R2 could be an ethyl group. Okay. We can have something like this, an alkyl group on the left and an aryl group on the right, as you can see here. So what is the example in this case? For this case, CH3, for example, a methyl group, an ethyl group, a propyl group, whatever, it doesn't matter. And aryl group, just like benzene here. Um, and finally, the final case, an aryl group, we can have an ether just like this. Aryl groups, the aryl groups or aryl groups at both sides of the ether linkage. So this is actually called an ether linkage. This is the ether linkage. Okay, so an example of this compound is something like um, benzene on the left, then oxygen, then a benzene ring. So any compound having having an oxygen in the middle acting as a bridge between two sides, this is actually an ether compound. It should be an ether compound, okay? So let's move on to the third the third category, which is the aldehydes. So let's check the aldehydes here. The aldehydes. Okay, an aldehyde would be an alkyl group attached to a formal group. So this is actually a formyl group. This is called formyl formyl group. C double bond OH. This is actually called a formyl group. So an example of this would be CH3 C double bond O, and here is H. What is it called? I'm not giving any names. I'm not teaching now the nomenclature of organic compounds. I'm just giving you an idea about the functional groups. Then in another episode, and just let me know in the comments if you want an episode or a video about the nomenclature of organic compounds. Okay, specifically aldehydes and ketones. Okay, so um, it could be, an aldehyde could be something like aryl group here and C double bond OH, right? So it, it could be something like this, a benzene ring attached to hydrogen. This is actually called, let's say it's okay, it's a common name. So this is the benzaldehyde and this is acetaldehyde, no problem with this. Um, Ketones, let's check ketones. Okay, ketones could be something like this, R, C double bond O, R. An alkyl group, let's say this is R1, this is R1. Alkyl groups on both sides of a carbonyl group. This is actually called a carbonyl group. Carbonyl or carbonyl. Some people call it carbonyl. Carbonyl group. Okay. So carbonyl or carbonyl group. This this gives this gives the compound the classification of ketones. Okay. Okay. Let's take an example. Something like this, CH3, C double bond O, CH3. This is actually acetone. Um, it could be something like the R groups are different. So R1, C double bond O, and R2, we talk about something like a methyl group on the left and an ethyl group on the right, right? Okay. It could be an aryl group on the left and alkyl group on the right, no problem. So let me draw it. Aryl group, aryl group here. So it could be something like this, right? Let's remove one. So what is the example here? Something like this. A benzene, then C double bond O, then let's say CH3, okay? So this is actually a ketone, right? Um, it could also be something like this. Two aryl groups, two aryl groups attached to the carbonyl group in the middle, right? So on both sides, we have two aryl groups. So we have benzene here, then C double bond O, and here we have benzene, right? So this is actually a class of compounds. Um, this is actually a ketone, right? This is actually a ketone, right? Then we move on to the carboxylic acids, right? So a carboxylic acid could be something like this, an R group attached to C double bond O OH. This is actually a carboxylic group. This is the carboxylic group. Carboxylic or a carboxyl group or a carboxylic group, carboxyl group or a carboxylic group, no problem. So it actually takes carbo and xyl, right? Carboxyl. Let's remove this IC. Let me remove it now. Um, Carboxyl group, just like this. Carboxyl group better. Actually the same, but more commonly, to be honest, carboxyl group. Okay, so this is a carboxyl group. It comes from carbonyl and xyl hydroxyl. So we removed the hydro and we removed the carbo the nile nile the nile suffix, and the hydro prefix, okay? And we got a carboxyl group here. I hope you got me. So one example could be something like this: CH3, C double bond O, OH. What is it? This is the acetic acid, or it could be something like this. Let me draw it above. An aryl group attached to a carboxyl group. So this can be represented by the example of a benzene ring attached to a carboxyl group. This is actually called benzoic acid. Then we have esters. The esters, we have aromatic and aliphatic esters, of course. Mm, let's talk about the aliphatic esters first. An alkyl group, aliphatic esters, an alkyl group attached to C double bond O, O, R. Okay. Actually, the C double bond O, O, this group is called the ester linkage. This is called the ester linkage. Okay. One example is, and let's check it, R1 and R1 as well. So let's write CH3, C double bond O, O, CH3. This is an ester. It could be something like R1, C double bond O, O, R2. So this could be CH3, C double bond O, oxygen. This is the ester linkage, and then C2H5. The nomenclature of esters, we will discuss it later. It could be an aryl group attached to an ester linkage, just like here. So this is an ester, and we can have an example just like this. An aryl group here, just like benzene, then C double bond O, then O, then R. R could be a methyl group, for example. A methyl group, for example, just like this. Or we can have both groups around the ester linkage to be aryl groups. So here is aryl group, here the ester linkage, and here is another aryl group. Then we can write it like a benzene here attached to an ester linkage, and then we have our benzene ring. Okay. Then finally we have phenols. Okay. In the first place, we have discussed the alcohols, and we said that alcohols is all about, or are all about, alcohols. Yes, alcohols are alkyl groups attached to a hydroxyl group, right? This is an alcohol. So you have to remember that alcohols always are aliphatic, okay? However, phenols are aromatic. So we have it here. Phenols. Here, the phenols should be aryl group attached to a hydroxyl group. You have to remember that, right? So a phenol could be something like this. This is actually carbolic acid or phenol or hydroxybenzene. It has the three names. Or it could be something like this. No problem. OH group and OH group, just like catechol. Or another OH group, it would be pyrogallol. Just remember, an aryl group attached to a hydroxyl group always is a phenol compound. Never forget that. And until then, see you in the next video.